What began as the simple discovery of small red dots eventually led to the greatest astronomical crisis of our time. No wonder, since the red dots were to turn out to be very early galaxies that appeared much too large and massive for their formation so shortly after the Big Bang. Since the early galaxies were in stark contradiction to our current theories, they were quickly given the nickname universe breakers. But now, the James Webb Telescope has once again set its sights on the mysterious objects and shown that our standard model of cosmology may not be as dramatically off the mark as previously feared. If you will, the James Webb Telescope is brilliantly fulfilling its overarching mission. Launched into the depths of space on December 25, 2021, Webb is set to revolutionize our knowledge of the universe. And sometimes an astronomical revolution requires completely overturning the established assumptions of the past. Designed specifically for infrared astronomy, one of the main tasks of the $10 billion device is to examine the first luminous objects and galaxies that emerged a few 100 million years after the Big Bang. James Webb is so powerful that, in theory, it could identify the heat of a bumblebee on the surface of the moon from Earth. But in practice, of course, Webb has not added fluffy insects to the star charts. Rather, it has revealed sometimes unexplained structures that should not really exist according to our understanding. The universe breakers. After the deeply impressed world public had marveled at the first spectacular Webb images on July 22nd, it was already time to move on from the overwhelming pillars of creation and exotic ring nebulae of the cosmos, and instead take a look at 6 peculiar red dots whose light took over 13 billion years to reach our earthly eyes. The ominous objects were hidden in the details of the images taken by the near-infrared camera from the early release program. After the team, led by Evolab from the University of Technology in Melbourne, became aware of the reddish shimmering structures, closer analysis revealed that the structures already existed 500 to 700 million years after the Big Bang. Basically, the experts had expected to find only tiny baby galaxies at best for this early phase of the universe. This is hardly surprising, since according to our models, there was simply not enough normal matter at that time for galactic heavyweights the size of our Milky Way to have formed. And so the astronomers were all the more perplexed when they found exactly that 6 galaxies that already existed at the dawn of the cosmos but were as developed as our own. Expressed in numbers, this means nothing more than that all the discovered objects already contained more than 10 billion, and in one case even more than 100 billion solar masses of stars. In view of this, co-author Joel Ledger of Pennsylvania State University initially thought that he and his colleagues must have made a serious mistake, but there was simply no way to find one. Why the standard model of cosmology has been shaken. And so it came about that Joel Ledger had no choice but to summarize the astronomical dilemma as follows. We have found something here that is so unexpected that it poses a real problem for science. His colleague and co-author, Erica Nelson from the University of Colorado in Boulder, added, even if only one of these galaxies is real, this pushes our understanding of cosmology to its limits. But why is that so? How did the discovery of 6 previously unexpected massive galaxies cause experts to find themselves in a full-blown crisis? Well, the reason for this is simple yet crucial. The only way to explain the existence of such massive galaxies at that time is to assume that the density of matter in the young cosmos was either 2 to 5 times greater than our models suggest, or that the early galaxies grew in a way that is completely unknown to us. Either way, we would have to critically question our understanding of cosmic evolution from the ground up. And even the vague suspicion that the supposed galaxies could in fact be other objects, such as dust-shrouded black holes, offers no less confusing an explanation. Because even in this case, there would have been significantly more stellar matter in the early days of the universe than previously assumed. Or would there? Well, new research results were recently presented at the 245th Conference of the American Astronomical Society, focusing on the influence of black holes. These findings could finally provide the long-awaited solution to this nagging mystery. The rescue for the standard model of cosmology? In advance of this, a team of astronomers, led by Dale KBSKY of KBY College in Waterville, compiled the largest dataset to date on these little red dots, or LRDs for short. They found that a large proportion of them contain evidence of gas movements that are typical of growing black holes. And indeed, the experts not only focused on the 6 objects mentioned above, but also on numerous LRDs that appeared in large numbers around 600 million years after the Big Bang, and abruptly decreased again about 900 million years later. While the extensive sample set was based largely on publicly available web data, the method of identification covered a wide range of redshifts. In the course of this, the researchers finally found that about 70% of the LRDs detected show signs of gas orbiting a supermassive black hole at a speed of 1,000 kilometers per second, literally screaming out for a typical accretion disk. In simple terms, an accretion disk of gas and dust feeds the mass monster by spiraling matter inward. Applied to the impossible red dots of light, this means that many LRDs could in fact be growing black holes, also known as active galactic nuclei. Stephen Finkelstein from the University of Texas in Austin summarizes the significance of this for overarching research as follows. These high redshift sources basically cease to exist at some point after the Big Bang. If these are growing black holes, and we believe that this is the case for at least 70% of the sources, it points to an era of hidden black hole growth in the early universe. And with regard to the much-discussed universe breakers, co-author Anthony Taylor goes one step further and states that this is the solution to the universe breaking problem, and for a very simple reason. Where most of the light comes from accreting black holes and not from stars, the bottom line is that there are significantly smaller galaxies, whose existence does not push our existing models to their limits. The mystery is not fully solved yet. So, have we finally overcome the biggest astronomical crisis of our time? Well, not quite yet. The full truth also includes the fact that, despite everything, LRDs are still accompanied by big questions. In particular, this includes the question of why they do not occur at lower redshifts. One possible solution to this is based on the assumption that growth occurs from the inside out. In other words, as the star formation of a galaxy expands from the core outward, less gas is deposited by supernovae near the growing black hole, which consequently becomes less obscure. In this case, the gravity monster sheds its gas cocoon, becomes bluer, and eventually loses its little red dot status. Furthermore, the LRDs do not shine brightly in X-rays, which makes them different from most black holes at lower redshifts. At the same time, however, experts know that at certain gas densities, X-ray photons can be captured, thereby reducing the X-ray emission. The future of LRD research. The James Webb Telescope continues to revolutionize our understanding of the cosmos. The discovery of these mysterious red dots proves that our understanding of the universe is still evolving. And with every observation, we get closer to answering the biggest questions in astronomy. And if you want your astronomical knowledge to keep evolving, simply press thumbs up and subscribe to stay up to date. We'll see you soon. Rocket Sparkles.